In this quick review video, we're going to talk about rationalizing a denominator. So the simplifying steps, if we're working with a fraction, generally we always want to make the numbers as small as possible. So if it's 2 over 4, we want to make it 1/2 instead. Right? We also want to avoid having square roots in the denominator. It's kind of just one of the rules of simplifying. And this process of getting rid of the square roots is known as rationalizing the denominator. All right, so what we're going to use is the fact that if you multiply a square root by itself, well, if you multiply anything by itself, that's the same thing as squaring it. And we know square roots and squares cancel out, and I'll just get x. So I'm going to use this fact that I can multiply a square root by itself to kind of get rid of the square root. So I have 8 over the square root of 3. This isn't fully simplified because there's a square root in the denominator. So to get rid of the square root, I want to multiply by the square root because those are going to end up canceling. But if I'm multiplying in a fraction, I have to multiply the top and bottom by the same thing. Right? 8 times the square root of 3, you can't really do anything with. You just combine them. But the square root of 3 times the square root of 3, like we just saw on that previous slide, that cancels out, and you get just 3. All right, and this one is fully simplified now. All right, this example, again, not fully simplified because there's a square root. So we want to get rid of that square root by multiplying the top and bottom by the square root. All right, the next step is the same thing. 4 times the square root of 12, not much you can do. When you multiply these square roots together, they cancel out and give me 12. Now we just want to keep going using all of our other processes. Can I simplify the square root? I can, because 12 is 4 times 3. And that 4 has a nice perfect square root, and that's 2. And since this is all multiplication, that turns into 8. And now the square root is as simple as possible, but what about the stuff that's not in the square root? 8 over 12 become 2 over 3 because they're both divisible by 4. So this would be the fully simplified answer. I've gotten the square root out of the bottom, and all the numbers are as small as possible. All right, last one, the square root of 3 over 5. I can split up square roots over a fraction. All right, not over addition, but over multiplication and fractions. Now I do the same thing, trying to get rid of the square root in the bottom. When I multiply 2 square roots, I can combine them into a single one, so 3 times 5 is 15. And the bottom, the square roots cancel and give me 5. All right, so now you know how to rationalize the denominator and simplify your fractions.